Hi all. In this video, we will discuss about user-defined functions. These functions must be declared and defined. If you are defining one user-defined function after main function, that function must be declared before main. This function declaration gives whole picture of the function, that is name of the function, what is the return type of that function, and type and order of parameters. This function declaration must be placed before the function call. And function definition contains the code that needs to complete the task. This function definition contains a function header and a function body. The code we have to keep in the function body. See example for declaring, calling, and defining of functions. Here, first one is you are declaring function before main. Our user defined function name is greeting. We are not sending any arguments, and this function is not returning anything. That's why we are keeping void there. Now, in the main function, we are calling this greeting function. Once you call, that control goes to function definition. This execution is performed. After completion of function definition execution, control comes back to the function calling place. After that, remaining code is executed in the main function and control goes to the uh, operating system. In any programming language, we have four basic designs for functions. How to take these four basic designs? That is, depending on the return type of that function. So that means how many arguments it is returning, and what are the arguments you are sending to that function. How many arguments you are sending to that function. So here first design is void function and without parameter. So void function means that function is not returning anything. Without parameter, that means we are not sending any arguments to that one. Next one is without return type with arguments. Third one is with return type without arguments or parameters. With return type with parameters. Like that, you can classify basic designs for functions. Now we see the first basic function design, that is void functions without parameters. Void function means that function is not returning any value. So void functions, we are not sending any arguments to that function. Observe this example. This is function declaration. Here in the function calling, we are not sending any arguments. So observe in the function header, we are taking that one as void. Just we are printing hello world, return. Just we are using return statement, but we are not sending any values to the calling function. That's why we are taking the return type as a void. Control comes here, remaining part of program is executed. So that is first basic design, void functions without parameters. Now observe second basic function design, that is a void function with parameters. That means some value we are sending from calling function to function definition. So here this function is not returning any value. So observe here, well, how we are taking function declaration. Void function name is print1 int x. This int x is the formal parameter. Observe this one, we are taking a value as 5. We are calling the function print1 with a value. So a value is assigned to x. So here a is actual parameter, x is a formal parameter. Now x value is 5 and we are printing x value. We are not returning anything. So that is void function. Like that we can take second basic function, design void functions with the parameter. So that is without return type and with parameter. Third function design is a non-void function without parameters. That means that function definition, user-defined function returning some value, but from the calling function, we are not sending any arguments to it. So here you observe get quantity void in the function declaration. So get quantity you are calling without sending any arguments. Control comes here. Okay. So here we are reading quantity value. We are returning quantity value to the calling function. So that quantity is assigned to amount and remaining program is executed. So like that we can design third basic function design. So that is with return type and without parameters. Non-void functions without parameters. Last design is with return type and with parameters. Those are non-void function and with parameters. Here in this case, observe we are calculating square of one value. So this function is returning integer value. That's why we are taking return type as int and we are sending one integer argument to this function. So observe in this function, main function, we are reading a value and after that you are sending a to the square function. Once you send that one, a value is assigned to x. Here we are calculating x square, you are returning that value, so that's why int we are taking as a return type. Once you return that value comes to this calling function place and that one is assigned to b and we are displaying that particular result value. So like that you can develop a fourth basic design. Next topic in functions is inter-function communication. How communication is carried out between different functions. So here these calling functions and called functions need to communicate to exchange data. So here data flow from calling to called or called to calling. So those are divided into three strategies. First one is downward flow. So the data from calling function to called function, calling to called is called as downward flow. So that is function calling to the function definition. Upward flow, that is reverse flow. Called function to calling function is called as upward flow. Bidirectional flow is communication in both directions. That one is called as bidirectional flow. The same thing we are representing in diagrammatic fashion. So calling to called is downward, called to calling is upward. Communication in both directions is called as a bidirectional flow. First, we will take this downward flow. Calling function sends data to the called function. That is one-way communication. So calling to called is downward flow. Here, copy of data items is carried out. Mainly this one comes under call by value mechanism. Here, while taking this downward flow, we have to use appropriate data types in function parameters list to receive data values. Next one is upward flow. Communication from called function to calling function is upward communication. So this is also a one-way direction. Calling function may use values passed from called function. Original values of called function remains unchanged. So here we are using address variable name in function call to pass reference to the variable. So while at the receiving place, we have to use the pointer variables. Next one is bidirectional flow. So here communication is carried out calling to called and called to calling. Here we have to use mainly addresses and pointers to perform this bidirectional flow. To implement this interfunction communication in C language, we have to use pass by values and pass by reference and what are the different return types, etc. First one, downward communication. So from down function, we are sending two values. A value goes to X, then 15 goes to Y. That is from calling function to called function data is transferred. So no return data is present here. That's why this is called as a one-way communication, that to downward communication. See another example for downward communication. I am calling down function a value and 15 I am sending. A value 5 we have initialized here. So 5 is assigned to X and 15 is assigned to Y. So here A we are taking and communication is carried out. These values comes to this place. So in the function definition, what are you doing? We are changing x value, that is x equal to x plus y. So here x value is 5, y value is 15. Those two are added and that result is assigned to x. So x value becomes 20. Y value is as it is 15. This is only a copy. So what are the modifications are taken place in called function are not reflected in calling a function. That's why this is a one-way communication and downward flow. Next one is upward communication. In the case of upward communication, we can either we can use return type or you can use addresses to send data back to the calling function. Here in upward communication, in this function, I am sending address of A and address of B. Once I send address of A is assigned to integer pointer AX, address of B is assigned to integer pointer AY. So now here you are assigning 23 to the AX, dereference operator AX. That means the value which is assigned there directly goes to A. So upward communication is performed. Same example we are taking in a diagrammatic fashion. So initially what we are sending address, we are not sending values. Okay, so we are changing values at A. So this upward communication you can observe. So to AX we are assigning ampersand star AX, that means dereference operator AX. Okay. So you are assigning some value, that value directly goes to A. Similarly, in the case of AY. So here to perform this, we require dereference operator. Whatever the strategy we followed in the case of upward direction, that is by taking address and dereference operator, same thing we can use in bidirectional communication with little difference. Here we are using indirect reference in both sides of assignment statement. The variable in the called function is first accessed for retrieving the address value in the right hand side. Here we are accessing the same parameter again to store a value in the left hand side. So here you can observe after and before assignment statement we are using dereference AX. So this like this we are taking this bidirectional communication. So observe this example. Here I am initializing A with 2, B with 6. I am sending ampersand A, ampersand B, that is address of A, address of B, that one comes here, star AX and star AY. So what is the thing? Actually, A, B values are there. We are sending address. That address comes here. Here, we are modifying those values by performing this operation. So, what is the there which is present after assignment? That is the right hand side of assignment. So that is original value. Previously, what is the value you send from calling function to called function? So here it takes 2 and we are adding to that one. So this modified value to this one left hand side, that one becomes 4. So that modification you can observe here. So like that you can observe bidirectional communication. So here you see another example, swapping function or exchange function. So here, what are the values? What are the things I am sending? Address of A and address of B. Those things are assigned to num1 pointer and num2 pointer. Here we are applying swapping of two values. So hold, we are taking one temporary variable and star num1. Dereference operator num1 means value at A we are changing. That one we are assigning to hold. So value at B you are assigning to value at A by using star num1 equal to star num2. Later, previously hold contains A value, that one is assigned to B. So like that we can perform swap operation, and the modifications which are taken place in the function definition, those are reflected in the calling function also. For the same purpose, if you use call by value, you won't get the correct result. That means if you use call by value, no upward communication is carried out, then the modifications which are taken place in the function definition are not reflected in the function calling. That's why for this bidirectional communication, mainly you have to use these addresses and dereference operator. See another example for bidirectional communication. Here I am taking two integer arguments and two integer pointer arguments. Those four I am sending to my function definition. A, B my integer arguments and quotient and remainder. Okay, so those addresses I am sending here. So in here for 4 memory is assigned. Okay. So now A is assigned to dividend, B is assigned to divisor, quotient and remainder we are taking those pointer. So quotient equal to dividend by divisor. Division operation, you will get the quotient value. By applying remainder operator, mod operator, you will get the remainder. So where modifications are taken place, those modifications directly reflected in quotient and remainder, which you declared, where you declared in the main function. Like that, you can achieve bidirectional communication. Thank you.